Most of the time, when faced with a budget constraint, consumers maximize their utility by choosing a bundle on the budget line at a point of tangency to an indifference curve. Most of the time, we can therefore use the Lagrangian method to solve for this utility maximizing bundle. However, there are exceptions. What determines whether or not you can use the Lagrangian method is preferences. In this video, I'll talk about corner solutions. There is another video that talks about a specific case of corner solutions for perfect substitutes, but this one is for corner solutions more generally. A corner solution is an optimal bundle in which one of the goods is not consumed. In other words, a consumer is at a corner solution when he uses all of his income to buy only one of the two goods. I'll show you how, at a corner solution, the tangency condition doesn't always apply. Say, for example, that consumers do have downward sloping and convex indifference curves, but the indifference curves are pretty flat. A flat indifference curve reflects a relatively small MRS, which means for another unit of X, a consumer is not willing to trade a lot of Y. This reflects a relatively weak preference for X compared to Y, or a relatively strong preference for Y compared to X. When preferences for one good, like Y, are pretty strong, depending on the relative price of X in terms of Y, a consumer might choose to buy only Y and no X. That's what's happening here on this graph. This bundle highlighted here is on the budget line, so it's affordable. But it's not on the highest indifference curve that could be reached. Instead, on this graph, the highest indifference curve that the consumer can reach is the one right here, where the consumer is spending all of his income on meals and not buying any books. Here we have a corner solution. Let's take a look at an example of this. Say Doug's preferences for X and Y can be described by the utility function you see in the problem. His income is 80, the price of X is 30, and the price of X is 10. First, let's take a look at the indifference curves. In this example, both MUX and MUI are positive, making both goods good goods, leading to indifference curves that slope downward. The marginal rate of substitution is diminishing in X and increasing in Y. Along a downward sloping indifference curve, X goes up as Y goes down. Because there's a negative relationship between X and the MRS, as X gets bigger, the MRS gets smaller, and so the indifference curve gets flatter. Because there's a positive relationship between the MRS and Y, as Y gets smaller from left to right along an indifference curve, the MRS gets smaller and the indifference curve gets flatter. The indifference curves here are downward sloping and convex to the origin. So you might think, okay, since the indifference curves are convex, I can use the Lagrangian method. Using the Lagrangian method, I've got the Lagrange equation as the utility function plus lambda times income minus expenditure on X minus expenditure on Y. My three first-order conditions have been written out, each representing a partial derivative of the Lagrange equation with respect to the variables X, Y, and Z, all set to 0. Using the methods described in the Lagrangian method video, I get here, which is exactly what I would get had I started with the tangency condition, or the MRS equals the MRT. From this tangency condition, I can solve for Y. At the optimal bundle, the value of Y will equal 3 times the value of X minus 10. This is an equation with X and Y. To solve for X and Y, I need a second equation with X and Y, and that second equation is right here in the form of the third first-order condition, which is also the budget constraint. When I substitute Y into this equation, I arrive at an X equal to 3, and when I substitute X equals 3 into the equation for Y, I get a -1. What's going on here? I think a visual will help a lot. What's going on here is that the Lagrangian method is looking for a tangency condition. And in this example, the Lagrangian method found one. It found bundle A, where the MRS is indeed equal to the MRT. The problem with bundle A is it's on the budget line in the region of the budget line where Y is negative. And Y can't be negative. Y is a good, like pizza, or a service, like haircuts. And you can't have a negative amount of either of those. So A, though a tangency, is not inside the affordable set or the budget set. This consumer can't consume bundle A and is instead forced to choose a non-tangency such as B. She chooses B because it's on the budget line and on the highest indifference curve that can be reached. On the graph, we see that at point B, the MRS is greater than the MRT, and we can see that down here with the math as well. Usually when the MRS is bigger than the MRT, the consumer gets more bang per buck from X and less bang per buck from Y, and so moves her income towards X, buys more X, and away from Y, buys less Y. But in the case here, the consumer is already buying as much X as she can afford and already consuming as little Y as is possible. B is therefore the solution to the question. B is the optimal bundle. Let's look at another case where we have corner solutions. In this example, preferences are represented by the utility function u equals x squared plus y. Income is 24, the price of X is 6, and the price of Y is 3. What's the optimal bundle here? Well, if I first start by looking at indifference curves for this utility function, I see that this is an example of indifference curves that are downward sloping but concave to the origin. Both marginal utilities are positive, so the indifference curves slope down, reflecting a trade-off between two good goods. And the MRS is increasing in X and constant in Y, so as X gets bigger and Y gets smaller from left to right along an indifference curve, the MRS gets bigger, which makes the curve get steeper. Whenever we have indifference curves that are downward sloping and concave, a tangency point will exist, such as A. So if you use the Lagrangian method, or if you set up that tangency condition, you'll find a bundle that meets that condition. The problem is that won't be the answer to the question. A isn't on the highest indifference curve that the consumer can reach, given her budget constraint. B is. You can see in the graph that B, on the budget line, is on a higher indifference curve than A is. Again, our usual math will find a tangency point, such as A, but in the case of concave downward sloping indifference curves, this tangency point won't be the optimal bundle. You might wonder how I know which corner is the optimal bundle. Well, an easy way to think about that is to check both corners. And by that I mean, if you only buy X, how much utility would you get from that bundle? If you only buy Y, how much utility would you get from that bundle? In this example, you get more utility from consuming the corner solution in which you only buy X than you would get if you only bought Y. Therefore, the answer is X equals 4 and Y equals 0.